Oxides. Yeah, iron oxide, rust, right? Copper oxide, pennies. You have experience with oxides. Do you have any experience with peroxides? Can you tell me a little bit about peroxides? Hydrogen peroxide. Hydrogen peroxide, what do you know about it? It's what? Disinfectant, maybe. What else? It's the big thing about hydrogen peroxide is it stable over time? No. What you'll notice about hydrogen peroxide is it's unstable. In fact, all peroxides are unstable. Since all peroxides are unstable, if we have a choice between a peroxide and an oxide, I'd pick the oxide because peroxides are quite unstable. In fact, peroxides are kind of dangerous. You know, do they allow hydrogen peroxide on flights? Airline flights? Well, it also depends on the concentration. But, you know, this was in California. Yeah, this is a very interesting. This was years ago. I looked at this story. Apparently, this person wanted to bring some hydrogen peroxide. They got a good deal on hydrogen peroxide. Hydrogen peroxide is used in gardening and other things, right? So they got a good deal on it. And so what they did was they took this. You know, household hydrogen peroxide is way less than 35%, but they took this 35% hydrogen peroxide and packed it in an ice chest and wrapped it up, and then convinced the person at the check-in, baggage check-in, to take it. So they were able to check it as luggage. And what happened was the plastic bottles had a split and it was leaking. And then it leaked through the ice chest. And then as it leaked through the ice chest, some of the hydrogen peroxide hit some fiber suitcases and popped those on fire, basically. So that's what happened. And so the flight had to be diverted to the nearest airport, and the fire put out. But anyway, cargo compartment smoldering. The damage to the baggage was more than 40,000. Of course, so hydrogen peroxide, is it stable stuff? No, not at all. And it has to do with this kind of bond it has, what we call the peroxide bond. And I think I showed that earlier. Did I show that earlier? This kind of oxygen-oxygen link here. It's not that stable, like you'd expect. However, in O2, it's stable. O2 is a little different, the type of link here. You know, O2 is fairly stable. It's still reactive. You know, it oxidizes metals. We got to prevent rust, right? Other things. But compared to peroxides, it's a lot more stable than peroxide. And so, yeah, I wouldn't just suspect this was a peroxide, but really I couldn't tell. You know, could have been. Could have been a peroxide. So we're just using chemical knowledge just to eliminate that as a low probability that this is lead 2 peroxide, and a high probability this is lead 4 oxide. How about this one? This one. On this one, we could do the reverse of the cross multiplication to get the charges quickly. And so the reverse of cross multiplication would be something like this. If I had CO2 S3, I know that this element is variable or fixed charge. This variable charge, I already know its charge. It's going to be cobalt plus 3, and so we're going to get cobalt 3 plus, and sulfur will be 2 minus. Then I have to balance them out. Balance it. I get 2 sulfides, but the 2 sulfides isn't, so I need 2 cobalts and 2 sulfides. Well, now I got too much positive charge, and add a 3rd sulfide in there. So we got. And so what would we call this? This is going to be called cobalt Roman numeral 3 sulfide. Cobalt 3 sulfide. Now, this is a bit unusual compound because if you knew something about cobalt chemistry, you'd recognize that this is a bit of unusual. All right, let's go on to acids. What element is present in all acids discussed in this chapter? Hydrogen. Good. Which of the 5 memorized ic acids? I didn't memorize it like this. I didn't even do that. So I just skipped all this. For the homework, I skipped it. Except for this table. This table we can do. All right, so we're given the formula. What's the name? HCl? Hydrochloric acid. It's got chloride. We have 3 possibilities. What are the 3 possibilities for anions? Ide, and ate. And so ides are going to get the hydro prefix and the X acid suffix. So this would be hydrochloric acid. Nitric acid, what's the anion there? Nitric acid, it's got to be a nitric acid, it must be nitrate. So nitrate, what's the formula for nitrate? NO3 minus 3 oxygen. And therefore the acid, how many H pluses do I need? Just 1. And so formula for nitric acid is HNO3. Let's go on to the next one. What's the anion here? Anion's PO4, what's the charge? Yeah, PO4 -3, which we call phosphate. And so if that's phosphate, it's an 8, therefore we change the ending to ic acid. So this should be phosphoric acid, but we don't call it phosphoric acid. What do we call it? Phosphoric acid. How about the next one? Hydrosulfuric acid. What's that one? Hydrosulfuric acid. What's the anion? So hydrosulfuric has got to be sulfide or sulfate. It's got to be sulfide with a D. And sulfide ion is, what's the formula? SO4, SO2, SO4, SO4, 2 minus. Is that right? Is that sulfide? Yeah, what is this? This is sulfate. The T gives it away. If you see a T, because what's the difference between 8 and ite? What's the difference between 8 and ite? It has more oxygen or less oxygen. That's it. And therefore, it's got to have oxygen. I does not have to have oxygen. I is just going to be S2 minus. And so if the anion is S2 minus, then how many hydrogen ions do we need? 2. Balance that out, and we get H2S. Now, a lot of nomenclature, just comes. These rules haven't started at the beginning of time, and have been fixed in stone since the beginning of time. What's happened is these rules have come and been modified, and the rules have changed over time. Therefore, not everything fits the rules nicely. You know, rules can be broken. And so H2S goes by different names. H2S we call hydrosulfuric acid. Hydrosulfuric acid. And so normally this is for H2S AQ. Do you know what AQ stands for? Aqueous, which means dissolved in water. AQ stands for aqueous, which means dissolved in water. So H2S, a little bit will dissolve in water and that forms hydrosulfuric acid. But another common state for H2S is H2S gas. When it's H2S gas, we don't call it hydrosulfuric. You know what we call it? We call it hydrogen sulfide gas. It's hydrogen sulfide gas, but hydrogen sulfide is naming it as if it were an ionic compound or a molecular compound. No, if this were named as a molecular compound, we would call it dihydrogen. Yeah, dihydrogen monosulfide. Now, dihydrogen monosulfide is toxic. You know, it has a rotten egg odor. I think it was about 10 or 15 years ago, somebody in Ventura, one of the oil wells, died from hydrogen sulfide exposure. But it's H2S. Do you ever hear this as dihydrogen monosulfide? Never. Nobody ever calls it. But that would be its proper name, right? Dihydrogen monosulfide. Everybody calls it hydrogen sulfide gas or hydrosulfuric acid. Does that make sense? And so the rules aren't consistent, but you just learn these as you go along. Okay, what's the next acid there? Oh, yeah, good. This is nitrous acid because nitrate is NO3, so nitrite will be NO2. And so nitrite goes to nitrous acid. Okay, how about hydroselenic acid? Hydroselenic acid. What would that be? H2SE? Yeah, that's correct. Hydroselenic acid would be H2SE. Give me another name for hydroselenic acid. Give me another name for hydroselenic acid. Nobody calls it dihydrogen monoselenite, unfortunately. Give me another name for hydroselenic acid. You know, hydrogen sulfide is a colorless poisonous gas with the smell of rotten eggs. What do you think hydrogen selenide is? A pleasant, non-toxic gas? No. Hydrogen selenide smells even worse than hydrogen sulfide. There could be something. And sulfides are known as the stinkiest chemicals that exist. And so, give me another name for hydroselenic acid. Hydroselenic acid. The other name for hydroselenic acid is hydrogen selenide. It makes sense because sulfur and selenium are in the same family, right? So this is hydroselenic acid or hydrogen selenide. What is hydrogen selenide used for? Let's take a look. You know the exposure limit of hydrogen selenide? 0.05 ppm over an 8-hour period. For hydrogen sulfide, do you know what the exposure limit is? Hydrogen selenide
appears to be worse or better? Worse. Chronic exposure to low level of hydrogen sulfide around 2 ppm has been implicated in problems. All right. So that's hydrogen selenide. Let's move on to the next problem. HClO4, what's the anion there? Perchlorate, yeah. And therefore the name of the acid would be? Perchloric acid is correct. And now we're at hydroiodic acid. What's the anion for hydroiodic acid? Iodide. And the formula would be? Well, it depends on the charge on iodide. What's the charge on iodide? We look it up on the periodic table, it's -1. And so we just need 1 H. So it's just HI. It's also in the same family as HCl. You know, HCl, HF, HBr, HI. They're all the same. Their properties are somewhat similar too, because they're in the same family. So hydroiodic acid, HI. What's this one? HClO2. The anion is ClO2 minus. Yeah, chlorite. This would be chlorite, which means this has got to be chlorous acid. So this is chlorous acid. And then we have selenic acid. Well, selenic acid must have what anion? Selenic acid. Selenic acid must have selenide? Right, it's not selenide. It would be selenide if it was hydroselenic acid, but it's not. Then that's the correct answer. It's selenate. So what is selenate? SO3 minus? No. Maybe you're thinking of SO3 2 minus, but you know what SO3 2 minus is? Sulfite. Sulfites. You know about sulfites? Antioxidants. Oh, this is not, right. Selenium is Se, so it's Se what? SeO4 2 minus, that's correct. And so how many H pluses do we need? 2, and so it's going to be H2SeO4. H2SeO4 would be selenic acid. Note the difference between selenic acid and hydroselenic acid. Hydroselenic acid was H2Se, selenic acid is H2SeO4. How about HBrO2? What's that? Is that bromate, bromide, perbromate, hypobromite? Bromide. Which one is it? Bromite or bromide? With a D or T? With a T? Bromite? Bromite's correct, and then what would the name be? Bromous acid. Bromous acid. There's some kind of joke about bromous acid. I forgot it. So you can look it up. let's go on here. What is the formula of arsenate ion? Arsenate. ASO4 3 minus? That's correct. ASO4 3 minus. Two ways of remembering this. One way is this raw memorization. The other way is to use the pattern, because arsenate is kind of similar to what other member of the family? Phosphate. And so arsenate and phosphate are kind of similar because they're in the same chemical family. And members of the same chemical family have similar chemical properties. And so in your bodies, you have phosphates. You know, you have phosphates like ATP, you heard of that? ADP, like energy molecules. You also have phosphates in your DNA, in your genetic material. You have phosphates. And so there's a NASA scientist, I don't know, did you hear about this? There's a NASA scientist studying extraterrestrial life. And they're thinking, you know, what if the elemental composition of the planet were different? Could you have life based on other elements other than, you know, yeah, maybe like silicon. Like silicone has revolutionized a lot of things, like cooking, you know, with silicone. You can't do that with carbon-based polymers. It just burns. But anyway, getting back to this, you know, how do you study extraterrestrial life? Well, you look for places where they have an unusual composition of elements, and one of those places is Mono Lake. Have you heard of Mono Lake? It's in California. Looks like this. One thing about Mono Lake is there are no fish. No fish. It's a dead lake. But it's not totally dead, because you know what lives in there? Bacteria lives there. And so the bacteria live in there. One thing that they know for a fact is there's a lot of arsenic in Mono Lake. And so this NASA scientist said, well, you know, what if the bacteria were based on arsenic and arsenates rather than phosphorus and phosphates? Have you heard that? Probably you haven't heard it because it came out a while ago. When did it come out? Let's see when it came out. I just closed it down. It came out a while ago. It came out in 2010. Sorry, not 19. It came out in 2010. And oops, I didn't want to hit that. So there's Mono Lake. And so what they proposed is that the life in Mono Lake is based on arsenic rather than phosphorus, like human life and everything else based on phosphorus. And if that's the case, then, you know, life on other planets, you know, they might have a different chemical makeup than life on Earth. And so this study, you know, was hailed in 2010 as bacteria that reportedly and unprecedentedly had rewritten the recipe for DNA, and the secret ingredient was arsenic. Which it totally makes sense because arsenate and phosphate kind of look the same. And so researchers led by then NASA astrobiologists had found the organism dubbed GFAJ-1 in arsenic-rich sediments in California's Mona Lake. They later reported in the journal Science that the bacterium thrived in arsenic-rich phosphorus-poor lab conditions. The team concluded that GFAJ1 must be incorporating arsenic into its DNA in place of phosphorus, which is essential for the DNA of all other known organisms. The find was exciting to astrobiologists who previously speculated that extraterrestrial life might survive in unexpected places if only such a swap were possible. Arsenic and phosphorus being chemically similar, soon after announcement, though, the other researchers tried to reproduce their results, and they were unable to reproduce the results. And other researchers started speculating that there might have been contamination in their sample. I think that's where it ended. The sample's unfortunate. But this is part of the scientific method. You know, the scientific method is you have a lot of critics, and when this paper came out, there were critics who were speaking loudly, and then you have to defend your paper, basically, or your work. The things that you might have missed, not have seen. So anyway, end result was this came out in 2010. You probably haven't heard about it because it's now been pretty much debunked. But it was a big story. I remember when this came out in the news. All the major news organizations carried it. But arsenate and phosphate look very similar. And so, you know, you can see what they would potentially think what they thought or hypothesize what they thought. I mean, it's not a totally unreasonable hypothesis. Unless, of course, you knew a lot of chemistry. If you knew a lot of chemistry, then you'd know something about arsenic that they probably didn't know, being biologists.
What do you believe? What do you believe?
No, I don't believe that because, you know, peroxides have an extremely weak bond. Well, the arsenic-oxygen bond is extremely weak too. It doesn't take much energy to break that bond, so that bond can't survive for very long without decomposing. You know, arsenic's fragile. Arsenates are fragile compounds. So it depends on what one we're looking at. But you know, your DNA would be breaking all the time. You know, as is right now, your DNA. You know how many times it's cleaved per day? When I was taking biochemistry, I learned this, but I took biochemistry decades ago. When I was in biochemistry, I learned that DNA is cleaved 200 times at least per day. And then the repair enzymes come in to fix the damage, right? But now it's got to be a lot more because decades ago we had a lot less UV. UV is the main culprit in cleaving that. Well, can you imagine arsenic? You know, if phosphorus is cleaved 200 times a day, arsenic's going to be cleaved 2,000 times. That's bonds in per day. So you got to have a lot of repair enzymes to fix that damage. That kind of thing. You know, these are things that chemists would think about as well. But anyway, that. So let's go back to here. So arsenate, that's correct. And did I get logged out again? So as long as we cover all the rules, then I'm going to stop pretty soon here. What are the names of TeO3 2-? What is TeO3 2-? Is that telluride? Telluride? No, that's not telluride. What is telluride? The D. Yeah, and so tell me the formula for telluride. Te2-, good. Is that tellurate? that tellurate? No, that's not tellurate because I know the pattern. Tellurate should have how many oxygen? 4. So this must be tellurite, and tellurite's correct. However, what about IO3? If TeO3 is tellurite, then IO3 must be iodite, right? No, IO3 is iodate. What are the formulas for zinc nitrate, calcium selenate? So let's start off with zinc nitrate. Is zinc fixed charge or variable charge? So let's take a look at the periodic table. Well, zinc is a transition metal. Do you see it's in that yellow block right here? So is it fixed charge or variable charge? It's fixed. And what is the charge? Do you see the connection here? Zinc is in what group? Group 2B. That means maximum positive charge should be 2 plus. Here, zinc is a fixed charge at 2 plus. How about cadmium? Fixed charge at 2 plus. How about silver? Fixed charge at 1 plus. How about copper? Not fixed. So copper screwed everything up here. Unfortunately, it was going so well, right? It was going so well that it screwed up the pattern. How about gold? Variable 2. Copper is +1 and +2 being more common. And there's another reason for it. The other reason is structural. Gold, the same thing. There's a structural reason. +1 and +3 for gold. And so, anyway, zinc is fixed charge at +2. So we have zinc, and then nitrate is, what's the formula for nitrate? Is it 3 oxygen or 4 oxygen? 3 oxygen. And what's the charge? Just count it down. 3, 2, 1. And so how many nitrates do I need? I need 2 nitrates, right, to balance out the charge. So it's going to look like this, ZnNO3 2. Is that right? No, I'm going to have to put parentheses in here, otherwise it looks like I have 32 oxygens, 1 nitrogen. This is going to be it. Two nitrates for every zinc. That would be zinc nitrate. Okay, let's go on to the next one is calcium selenate. So calcium is a fixed charge or variable charge? And what's the charge? 2 plus. What is selenate? Well, is that 4 oxygen or 3 oxygen? Because it has a T. So is it 4 oxygen or 3 oxygen? 4. So for sure I know selenate's got to be SeO4, but I don't know the charge. So we count down the charge from what? Not from boron, we count down the charge from silicon. So it goes 4, 3, 2. And so selenate must be 2 minus, and calcium selenate, it just balances. It's going to be CaSeO4. CaSeO4. Calcium selenate. What is the name of NH4BrO2? Hey, you know what? Is this an ionic compound or molecular compound? This looks like a molecular compound, right? Because this consists of all nonmetals. However, it's not binary. This would be a ternary molecular compound. But it's not a molecular compound. Even though this compound consists of all nonmetals, 100% nonmetals, we still consider it an ionic compound. Why? We consider it an ionic compound because I should recognize NH4. I've memorized NH4. What is NH4? Ammonium ion. And so I got ammonium, which is the NH4 plus, and I know BrO2. What's the charge on BrO2? If NH4 is plus, BrO2 must be -1. And so the name for this is going to be ammonium, and then what's the name of the anion? Ammonium, okay, so BrO2, sorry, not BrO4. What is bromate? BrO3. So BrO2 must be bromite. So this is ammonium bromite. Can you name these? This one would be hydrogen carbonate. Hydrogen carbonate also goes by the name bicarbonate. Bicarbonate. This one's called hydrogen tellurate. This one's called hydrogen, not sulfate, sulfite, hydrogen sulfite. Those are acid anions. And so I think we've done everything except for hydrate. Let's just do one or two hydrates and then we'll end. What is this one? Nickel or nickel 2? Nickel 2 sulfate, nickel Roman 2 sulfate. 6 is hexahydrate. What is this one? KCl. Potassium chloride or anhydrous potassium chloride. But nobody really says anhydrous. We'll just call it potassium chloride. How about this one? Sodium phosphate. You don't know this, do you? You don't know this, so you just call it 12 hydrate. But this would be dodeca, do-2-10 hydrate. But anyway, getting back to this, have you ever looked at laundry detergent? Laundry detergent, you know what they call this? They call it trisodium phosphate. Trisodium phosphate. But we don't follow that rule, and we're breaking our rules. But the rules aren't set in stone. And so I'm going to stop here. This should get you started on these. And then let me pass back the test.